So the kinds of dependencies we support today are a require dependency, which is the very straightforward one. This package has to be there at the specified version or higher. Require any allows you to specify multiple ones. You say this or this or this or this, which is handy if you need postfix or send mail. Optional dependencies are used to say a minimum version at which a package must be present. This is handy if two packages which are not delivered by the same group exchange content. So you can avoid the problem of having the wrong version mismatch and have both packages try to deliver the same file, which is not allowed. Conditional dependencies, if the predicate package is installed, then there's a required dependency on the other one. We're using this. We haven't implemented the distro. Solaris is not yet using this dependency. That's there to allow us to decouple various interpreter plugins. So nobody delivers Tickle plugins unless the base Tickle package is installed, and we can basically reduce a lot of it, the things that get tied up together. All the interpreters get kind of locked together in a big wad because they have so many plugins for each other, and we can untangle that mess in this way without having people have to remember this stuff by hand, so the results are automatic. We have origin dependencies, which allow us to specify the minimum installed version of a package before you can install this one. This makes handling things like grub bootloader changes. We're going to be switching to grub 2 at some point. This makes this feasible, so we know that we have the right tools involved, and we can express those dependencies both as the version of a dependency on the version we're upgrading from, and the dependency on the system that's currently running the upgrade, so that we can make sure that things work correctly. We even have exclude dependencies, although we haven't found much use for them. We understand that some systems need them, so we can exclude, so two packages can agree to disagree. And we have incorporate dependencies, which we use to to define a surface of versions that work together. And this is where a lot of the mechanism that we use to keep the kernel builds consistent, for example, is done using incorporations. And all the consolidations that comprise Solaris are done with that. Question in the back? Do conditional dependencies suffer from the problem that patches have, which is that you end up with an incomplete package graph or a dependency graph when you install the missing component? And the answer is no. The SAT solver, when you install the piece that triggers the dependencies, all the dependencies are a complete solution is maintained. So you may install one package and update. You may end up installing 15 others as a result. And it computes that graph and installs all the dependent pieces. The system will not allow you to go into a state where package dependencies are not satisfied. There is no -F flag. All right? You can't force the system to install packages that don't work together. If those of you who feel that you know more about the packaging system or the package dependencies than the publisher of the packages did, you can always receive the package with one. You can pull the package down, edit it trivially, and then publish it locally. And then you have your own. Then you have you can break the package in a variety of different ways. But then it's you break it, you bought it kind of problem. It's now your particular problem, and it's not something that's a support issue. For those of you who've used the -F flag for a while and then tried to fix your system, you're probably well familiar with the problems of trying to untangle a broken package graph. Was there a question there? Yeah. The fMRIs you can't use a wildcard in the name, but you can use any part of the version may be omitted, including the entire version. That works correctly. Renames work, although conditional triggers do not work right now with the rename. The dependency works across the rename. The conditional does not support rename. So if the target, if the conditional dependency is on that thing gets renamed, then the rename will still. That's one area where we're kind of waffling back and forth. I'll say that right now. But generally, Conditional dependencies are probably placed by the publisher of the package because he understands the issues involved. So those should be updated all at the same time. But we could consider that a bug. No. We got rid of admin files. Package is not an interactive operation. There are no questions. The publisher cannot ask you what the IP address of his Ethernet driver should be. There is no mechanism for that. We decided that chatty post-install scripts were a bug, especially when it came to automated installation. So we can talk about that some more, but yeah, there are no admin files. Yes, you can undo the operation. If you've rebooted, of course, you have a different boot environment. We also are right now creating snapshots, and you can always install, any package can be installed in a clone of the current boot environment. You just say require new BE, and it will create a new boot environment for you, and we're also considering adding one as a backup, so you can say, okay, things, you can back up the operation. So you're looking for a really quick way to uninstall all the things you added in the last packaging operation? Right. You basically have to uninstall the various pieces. You cannot get yourself to a broken package graph by uninstalling various components. We used to allow you to break the system in that way, but that caused some very interesting problems for people. So we require that the package dependencies be correct, and that they be satisfied on the image today. So we would back out the operation. Right? You say, okay, let's not do that. Let's not install that piece of software until we correct whatever problem is causing your system not to work by adding packages. The question is whether or not dependencies are automatically installed. Yes. And the follow-on question was, can you stop it from installing things that you know will break your system? And the answer is, we have not yet implemented the package freeze, but the easiest way to do that right now, if you have a list of packages you do not wish to have installed on your system for any reason, was to create a two-line package or whatever that excluded those that had an exclude dependency on the packages you don't want. Install that, and that will prevent those by any packaging operation that attempts to install either of those two packages as a result of transitive closure of dependencies will fail. It'll tell you why. It'll say, administrator says, can't do that. Okay, going on with signatures. Signature used to carry the manifest signing data. They contain the you can add additional signatures to an extant package without modifying without impacting the other signatures that are there. So the signatures don't include each other in the hash, in what's hashed. This makes it possible for your QA organization to sign a package without affecting Sun signatures, for example. And the signatures, because the manifests contain SHA-1 signatures of the files that are a part of the package and the rest of the information, they form basically a Merkle or hash tree that basically completely defines every component that's in the package. And there's a variety of different signature requirement policies that are present. You can require that packages be signed. You can require that packages be signed by a particular publisher. Solaris packages are not signed in the first Express release due to some internal process issues, which you're still getting straightened out about who gets to hold on to the signing keys, et cetera. More publishers. So you can actually, the repositories, one particular repo can be configured and you can have a bunch of different publishers that they're in. And the repo provides a catalog and usually also provides search operations. You can access the repositories via a file path, either locally or via NFS or from a CD or HTTP or HTTPS. And we're coming up with an on-disk, which is a transportable single file format, which allows you to basically put a repository in a single file. Obviously, you want to be a little bit careful about how big a repository you carry around. You don't want to carry around too many gigabytes. And multiple repositories can be added together. In other words, you can take a repository over there and copy it into the one you already have locally. Okay, so packages can be installed, uninstalled, updated, or downgraded under certain conditions. And if needed, they can also be checked and repaired. So we have verify and fix operations as well. One of the interesting things we chose to do is that we actually combine all the changes to be made in the system in a single, refer to it as a meta package. And we sort that and apply that in the correct order. That means that two packages can exchange data, including editable files, et cetera. We can move editable files around, and we keep track of all that so that the correct thing happens. And if the same files if the files move from package to package, we don't actually download new versions of them. We figure out that if the same file is moved, we save that file for you and move it over. And as noted here, you can have cycles. Unlike SVR4 packages, you can have a cycle in the dependency graph. And the same with patches. We don't, that's completely okay. And you can have an arbitrary exchange of content, which makes it possible to rename packages, which was difficult before. Okay, we have this concept of variance, which is how we implemented fat packages or multi-architecture packages. And we basically publish a single architecture version, then merge the two together. And a particular variant is set at the image level, so you can't have half your image be Spark and half be x86. The image is either Spark or x86. And facets are a way of marking things that are optional in the package. Very similar to variants, they just don't collide. They cannot collide, and their default, they're all true. So the default behavior is to install all the locales, for example, or all the developer bits, the header files, and everything else. Both variant and facet attributes can appear on any action in the package, including dependencies. So the system you can construct fairly complex environments. We do have mechanisms to affect install time changes. In particular, we have a series of tags that can be placed on an action that cause the associated the named SMF service to be restarted. And there's a whole bunch of them here: disabled, refreshed, restarted, and suspended. Right now, we're basically just using the restart. We haven't found any particular need for the others, although we anticipated that they might be needed. And this mechanism does not come into play when you're installing the package on a non-running system. In other words, with the with a -R command to run on a different, to install the package on a different image. In that case, these services are started at boot, and the same process of self-assembly takes place, where the software assembles itself at boot time. We have a reboot needed tag that appears on files that if this file is modified or removed, the system, a reboot is required to make this effective. And drivers are so tagged so that we can automatically figure out whether or not we need to reboot. And this is the mechanism that we use to tag things. And so even if the package contains things that might need a reboot, if none of them change in the particular operation you're going to from one version to another, you won't need a reboot. And this is one of the way we're reducing the amount of the number of times you need to reboot to install patches. A few practical examples. Here we are installing GIMP. So it computes the package dependency graph. In this particular case, I just uninstalled it, so I only had one dependency. It doesn't need to create a new boot environment. It does need to restart two services. It turns out that we rebuild the menus as a result of the The GNOME system menus, because GIMP shows up in them, those are automatically rebuilt when the package is installed or uninstalled. And then we go through the download phase, which does a little curses thing, and it pulls down megabytes. Here we do the install phase. This particular package contained nearly 2,000 actions of one sort or another, mostly files. And then we did some indexing for the search. And that area still needs a little bit of work to improve performance. Okay, here we update the packaging command itself, so it's a little confusing. Package, update, package. And we go through and download a new version, which only is half a megabyte. We updated 240 files. And again, did the same kinds of indexing operations. These things work just as like, there's also a GUI version for those of you who are fond of using GUIs to perform packaging operations. That's, most of the time we've just used the text, the command line. And here we update all the software, and this is basically what happens when you update the operating system. This thing says update, there's no arguments given, so it attempts to update every package that's currently installed on the system. One of the interesting things is here that you can actually pass wildcards and stuff to update, to actually tell it to update a particular class of package, or any, you can use matching characters to select the packages to update. In this particular case, it found nearly 800 packages that had newer versions available. It decided, yes, it needed to create a new boot environment. We downloaded them. The size of the transfer was actually fairly small, about 200 megabytes, to update those 800 packages. Again, we computed that as the result of the difference from where we were to where we were going. We removed 2,500 typically files. We installed nearly 4,000, so we picked up some software. And we updated 6,000 files. Okay, and then there's some text. We now have some license text that's being catted out as a result of the legal bills, and we created a. You can tell this has been around a while. My system is still labeled Open Solaris. It creates a new. It creates a clone of this operating system and tells you, and it turns out to be Open Solaris-40, and it's set to be the next active boot environment. Next time you boot, it'll be running that particular version of the OS. So, and this whole thing takes basically whatever time it takes to download. Takes a minute or so to compute what it's going to do, and then does the download operation. So this has basically become the way that the developers at Sun update their operating system. We used to use this thing called BFU that copied the kernel and splattered it on top, and the developers never used the packaging system itself. One of the big goals we had was to eliminate the need for BFU, to make it possible to update the operating system, to completely update the operating system in 2 or 3 minutes, and maybe 5 if you're on a slow link. And then we could move, then the developers could update their OS every single day. They could upgrade the other components, not just when new versions of X and GNOME and the other consolidations became available, those packages could be installed. We would get a lot better testing of the upgrade mechanisms themselves by using it internally. And this has been successful. Nobody's using BFU anymore. So now everybody, when we do internal development, we do the same kind of upgrade that customers will be doing for their own express bits. So here's an example of some of the searching commands that we can do. I was looking for nmap, and I gave it a path name, because I happen to know its name is nmap, and it found it in these, and these two both, the way my system was configured, both those two versions could be installed. This is the one of the Solaris Express candidate releases is available as well. And that's what the search was doing. And here's, I looked for a package called snort. That wasn't installed because I did a package list operation here. And then I listed nmap, which I did have installed. And here's an example of wildcards, okay, where I passed a series of wildcards into, and I found 2 packages that had the letters OSNet in them. And this package here, consolidation OSNet incorporation, is one of those constraint packages I talked to you that's full of incorporate dependencies. And it describes the surface, a compatible set of builds, in this case 153, that could be installed on your machine. And this one here, I think, is the packages that are, this particular thing, which is a series of requirements, is a package that allows you to build ON. Whether there'll be an LU-like sync facility to sync up the logs. Today, the logs are in the root file system, and they are not shared across boot environments. So, but you are cloning the current log. So, I guess what I'm going to drive at, we're going to change that, and the logs will become a shared file system across all boot environments. And so, there's no need to actually sync the log because you'll be able to see every time you boot, you'll be logging to the same set of log files. So I think that answered the question. In general, the mechanism that was used with LU to try to attempt to copy very administrative operations from place to place was error prone for us and not very successful. And so the plan is not to go down that road. We simply clone the currently running file system, or you can clone other boot environments if you wish, and you get exactly what was in that boot environment, and then you apply your packaging changes to that. I think that's a little bit more predictable than trying to have some algorithm for updating things, whatever the developer thought was necessary. If we have alternatives in that space, if we need them, we'd rather not go down that path. It turned out to be quite problematic. Is there any way to clone the installation quickly using packaging? The plan here is probably to, so are you looking for something like a FLAR system? Okay, today there is we don't have a FLAR mechanism in place. We could do something, it's very easy to do with the packaging system. The question is what to do with the editable files and other content you may have installed on the system using tarballs or SVR4 packages or whatnot. So those typically what we've used in the past, the FLAR mechanism basically built a CPIO archive of your system and moved that from place to place. I don't know what that's under discussion, what the replacement will be for the FLAR stuff. The question was, how much space should we allow, first of all, what happens to the package after we install it, and how much space should we allocate for being able to upgrade? Currently, the default policy on the download cache is to keep things in place, although that's configurable. So the download cache tends to grow. What that does mean is that if you're repeating the operation or you want to give the package to other people, it's really easy. Our experience has been that an OS update from Express build to Express build takes 300 to 400 megabytes. So you basically can use a rule of thumb to allocate space. This generally isn't an issue nowadays except for people doing virtualized environments. And you want to make sure that there's kind of I would not configure anything with less than 10 gigs of space. That would be, I would think it'd be a minimum of, and then you can delete your old boot environments and recover the space. And we're working on better policies for pruning the download cache and manifests. Space management is still an area we're working on. That part of the system is not yet completely where we want it to be. So at this point in time, I would recommend configuring more space rather than less. Don't try to pare that down. For those of you who've run out of space on ZFS, you'll remember that you'll have to look around for things to get rid of, file systems to get rid of. Usually what I use is I delete the dump device, and then I can get things out again. Then I can recover from that, and then I can restore it when I'm done. Yeah, you pass the -V option to the commands, and we give you a lot more output. And you can actually pass multiple -Vs, and then it gets very chatty, but it certainly won't fit on the output of the slide. So yes, but that's a good question. Do I have an example of which packages it will update? Right, typically what I would do is I would say package update -NV. -N, don't do it, just tell me, and -V, show me the exact, and it'll tell you exactly which packages get updated. If any packages are obsoleted, do they go away, and if any new requirements are installed. And I use that quite a bit for debugging that information. Yes, I can describe it in a few steps. It pulls the latest version of the catalog from your publishers, or if you tell it no refresh, it will use whatever the last version it got. And it will look for it will attempt to, using the dependency information that's extracted out of the manifest and placed in the catalog, the SAT solver will attempt to construct a more up-to-date version of all the packages you have installed on the system, and look for a solution that updates as many of those packages as possible while obeying all the constraints that are there. It then downloads the manifests for those packages that it doesn't have already from the whatever repositories you have configured, which could be Oracle. If you have a local cache of those, it could be a local thing on your own WAN. It could be off of a DVD. And then it compares the manifests for the packages that you have, that it's proposed to install with the manifests that you have installed, computes the difference, and it identifies what needs to be downloaded. It downloads that, and then, if necessary, creates a new boot environment, and then updates, performs the removal, install, and update of any of the actions that are on the new set of manifests, and then writes the information about what packages are now installed on the system, and that's how upgrade works.
So as a follow-up, will this new model have any effect on the Oracle Sun support model?
Almost certainly. I've been working closely with the people we've all been working closely with the people in the support organization for making it easier to help them leverage the new technologies here. If for any of you who had a support contract under Open Solaris, you'll have been getting periodic SRUs. I forget what SRU stands for. Something it's an update of which basically were a series of bug fixes that were delivered. And then the people on the support contracts would be pointing at the support repositories, and when a new version became available, they could update to that new version. And they would be publishing, basically, they just rev whatever packages got new versions, and they can install those new pieces of software. So there's a lot more flexibility with this system. In the previous packaging and patching system very much constrained how support could work. And one of the things that we did here was to try to make this as flexible as possible. For those of you, did anybody here ever install IDRs? Which was the interim diagnostic relief, I think is what it stood for. The IDR mechanism also uses the versioning and incorporations and allows us to basically deliver custom fixes to a particular customer automatically. If they want to install that, they can. And then when the fix is integrated into the mainline, it's transparent. They get transparently upgraded the next time they do an upgrade operation. They go right back onto the mainline bits, and the IDR is automatically uninstalled. And this is a big improvement over the previous mechanism, which basically required them to manually uninstall the change and might require multiple reboots, et cetera. That's correct. Works. That my system on my desktop has 5 or 6 publishers of various bits. So I'm running nightly bits from the X consolidation, nightly bits from the ON, which is the kernel group, and then the stock stuff from various other, basically the Solaris publisher for the other stuff, and the system figures out what the net, what it should do, and I just image update periodically. Every week or so I get a new kernel and various other bits as they are available. And sometimes that's a surprise, and sometimes it's a happy surprise, and sometimes it's a not so happy surprise. But that's part of living on the edge.